All right, welcome back to Computer Science S75. This is lecture 1 in which we actually dive into PHP. So you pull up your browser, you hit www.google.com, and you hit enter. Can we play back this story? What happens first? And try to impress everyone with as much technical detail, but just one step as possible. Give me one step in this process. You have hit enter. What happens? Yes? OK, so there's some communication with the DNS server, whereby your browser asks the local operating system, what is the IP address of google.com. If your operating system itself does not know, it in turn asks the local DNS server. And who typically owns or controls these DNS servers? Yeah, your ISP. So Verizon, Comcast, Harvard, your company, anyone along those lines. And if your company or your ISP does not know what the IP is for google.com, what happens next? Excellent. They probably know some other DNS server, and so they ask a bigger fish, followed by a bigger fish, and so forth. And worst case, there are these root servers that at least know where the other authorities are for the various .coms, .nets, .orgs. And the reason that all works is that when you buy google.com or your own personal domain, you at least have to tell your registrar what. Yeah?
The DNS server of where you're getting your website.
The DNS servers of the hosting company or whatnot where your website lives. And that's typically called NS1 and NS2, just conventions. But the important detail is that there's usually 2 DNS servers that in turn know your website's IP address, knows your domain name's email servers, and the like. OK, so now my browser knows the IP address of google.com. What happens next? Yeah?
Well, it sends a GET request.
Good.
Good.
So we told the story of the virtual envelope, aka packet, and that's sent from point A, you, to point B, Google. And inside that envelope is this message, get me, / and then there's some reminder of the protocol that's being spoken, HTTP/1.1 or whatnot. What's also inside of that packet? What amount of information?
Could be a reminder of what actual web address the user typed in.
Good. So a reminder of the address the user typed in, which is the host HTTP header, and this is crucial for what feature offered by today's web servers? Someone else, yeah. Virtual hosting, whereby you can put many websites on the same physical machine and even on the same IP address, because browsers, thankfully, will remind the server what host name was actually requested so that the web server can distinguish between your website or someone else's website and so forth. All right, so this virtual envelope goes to Google. Google opens the envelope, so to speak, sees get / realizes, oh, you want the root of our website. In Google's case, that's all of the HTML and other assets that compose their homepage for searching. And so they respond with a packet of their own or more packets of their own, inside of which is all that HTML. Your browser receives it, renders it, connection is closed. Now, in terms of more subtle details, browsers these days are fairly smart in that rather than ever have to ask the operating system, Mac OS, Windows, whatever, what the IP address is of google.com, a browser will cache that IP address typically. So this just means it's slightly more efficient than asking the operating system and certainly more efficient than asking local DNS servers. But there's a gotcha, and one of the themes of this course will be to try to point out some of these details, because if you are not just a user, but you're actually a web developer trying to build new websites, suppose that the IP address has been cached, but suppose that you move the website to another server or another virtual machine. There are these gotchas you might run into, and so one of the recurring themes of any sort of web development, especially in this PHP world, is constantly be clearing your cache. And one of the upsides of using Chrome, frankly, for primary development is it has incognito mode, which while usually is used so you can browse sketchy places online, can also be used to a developer's advantage in that it will prevent cookies from being saved and other details from being cached. But even then, it's not perfect. And even I often have to quit the browser entirely, clear my cache manually. If you ever notice anomalies happening or like, I know I changed that file, it could just be some stupid cache issue. So put that in the back of your mind so that you don't waste 10, 20 minutes some night this summer chasing down a bug that you actually already fixed. Caching takes many forms, and DNS is just one of them. All right, so any questions on that big picture of HTTP? All right. So where does this all fit in? So this is the picture we essentially just painted verbally. So what's on the end of point B? In this case, Google or some other server. So one of the most popular web servers out there is Apache. This is freely available software. It can run on Linux computers, Macs, Windows computers, but it's super common in the Linux and Unix world in particular, and those tend to be machines used for web servers these days. It is the A in LAMP. So LAMP is just a silly buzzword, Linux, Apache, MySQL, PHP, and that's just a buzzword saying I'm using all of these various technologies. But common jargon in the industry is to say that I'm running a LAMP stack. And that just means you have Linux as your operating system, Apache as your web server, and so forth. And so there's nothing technical about the term, but we'll be looking at the individual pieces. So one of the latest versions of Apache is 2.2 point something. This is the documentation there. I will say from personal experience, I've never found it the most user-friendly. So frankly, Google is a better friend, to me at least, than Apache's own website, stackoverflow.com, serverfault.com. These are wonderful places where smart technical people post generally useful solutions to common problems. So keep an eye out for make use of those resources as you see fit. But what are the kinds of things that you can do with the web server configuration? Well, virtual hosting. So this is a representative snippet from a file called httpd.conf. And let me just pull up a little scratch pad so we can type out some notes here. The blackboards are occluded by the projector here, so we'll use TextEdit. So this just so happens to be the name, typically, of a configuration file. However, you might also see it as apache.conf, apache2.conf. It really depends on your operating system or the distribution of Linux, for instance, that you're using. But the important takeaway is that this is typically the main configuration file for an Apache-based web server. And Microsoft's IIS server has similar features. There's other web server software, but Apache's definitely among the most common. And here's a representative snippet from that file that apparently is implementing what feature for the web server, if you can infer. Kind of just guess by reading it. Yeah.
Well, first off, it's a port 80, so it's a regular website.
OK, good. So you see a port 80 at the very top there, which suggests it's indeed a sort of standard website living on a standard port. What else comes to mind? What other feature is being conveyed by this config? Yeah. Database. Oh, where are you inferring database from? Is that 443? Oh, so not 443 is actually used for SSL. So there's two pieces here. And we'll focus on both. But first, the top one, port 80, is sort of the simpler of the two. So let's look there first. So I'll pluck this one off. So virtual hosting. This feature whereby a web server can use the same IP address for multiple websites is implemented literally by way of a file like this. This is telling the web server, and the top thing there is just a comment. This is telling the web server, hey, define a virtual host, a vhost, on port 80 of any IP address that this server has. So star denotes anything, and in this case, it's meant to mean an IP address. And this is relevant because if the web server just so happens to have multiple IP addresses, this is a wildcard character that just says, doesn't matter what IP address the request comes in on, go ahead and just listen on port 80 on all of those IPs. So another common thing, especially if you're developing on your local virtual machine, which is increasingly common and is, again, what we'll do in the class. Sometimes you do need to know the IP address, especially in various cloud environments. So just be mindful of sometimes star is not sufficient unless you have a configuration, another layer of configuration that I'll wave my hand out for now because we're just looking at a snippet here. So this says, listen on port 80 on any IP address that this server has for incoming requests. Now, when requests do come into the server, thankfully, they should have that host : HTTP header that reminds the server what this request was for. So if you skim through some of this, and let's skip the top part now, server name, this is where the vhost's name is actually defined. And we'll see it down here, too. For the SSL version, the name of this website will be the same. But I've also defined what we'll call an alias, which is just what in this case? Quick sanity check. Yeah. Exactly. The alias here is just cs75.net with no www. So this is just one of the steps necessary to ensure that both www.cs75.net work and cs75.net work. So the quick story I told on Monday about certain websites just not working with just something.com or the like is because someone did not think to configure a fairly minor detail like this. Again, this is Apache, but other web servers, Lighty, Nginx, and others have similar features. So this is one step. And just to tie Monday to tonight, what was the other key detail that you need to do to ensure that both work, both www and no www? Not a redirect. Redirect is really just to ensure the user ends up at the place you want. But you want both destinations fundamentally to work. So we needed a DNS record, an A record in particular. So we needed to specify that cs75.net itself has an A record, and we need to specify that www.cs75.net has an A record, or what other type of record could we? Multiple aliases, which we called CNAMEs on Monday. So CNAME or canonical name. Now this too is sort of a corner case technically. Unfortunately, you cannot generally make CNAMEs for the root of a domain. cs75.net cannot be a CNAME for something else, but something with a host name, www, FTP, mail, .something.com, those can all be CNAMEs. And that's a bit of an oversimplification. You can have cs75.net be a CNAME technically, but things like email tend to break as a result. So let me just make the blanket statement that this has to be an A record, this can be an A record, or a CNAME. So just little things you need to keep in mind when setting up, for instance, your own domain name that you've just bought. Server admin, so this is just a fluffy detail so that if there's ever an error on your website and you see like 404 or something like that, if you haven't customized the error message, the footer of the web page is generally going to give the email address of webmaster@something.com. In this case, we're telling them to use this address just because. So it's not something like webmaster, which doesn't exist in our case since we're such a small shop. Lastly, custom log, error log, these kind of do what they say. It's just specifying the folder in which you want logs to be stored. And the most important line here, though, perhaps, is document root. Now, this is kind of crazy long and cryptic. It just is what we as a class decided to do in terms of the layout of our hard drive. However, all this is telling the virtual host is that the HTML files or PHP files, GIFs or pings for this virtual host called www.cs75.net live specifically in this directory on the server. Very often, this will be a much shorter path for normal people, but we've kind of laid ourselves out fairly hierarchically, which is why it's so long. But that's all it means. All right. Any questions? And again, this is something that for the first project, you'll have an opportunity to tinker with and even break if you want, and you'll be able to restore it rather easily. All right. So the virtual host on port 443 is a little more interesting, but also mostly a duplicate, but the few lines are new. Which ones jump out at you is obviously new? So all the SSL stuff at the bottom. So SSL is kind of a pain to set up, at least with certain web servers, whereby you have to configure a few files. So what is SSL? SSL is Secure Sockets Layer. This is the protocol that websites use to communicate securely with browsers. But what is necessary before you can actually use SSL on your website? Does anyone know? What's involved in doing this? Yeah? Exactly. You need to distribute a certificate that the user will need part of, will need to get somehow from you. Thankfully, it's all automatic. So how do you go about getting an SSL certificate? So there's a couple of things you can do. You can either create one and sign it, so to speak, yourself, or you can pay someone else. And have you ever been to a website that said, whereby the browser, upon visiting it, yells at you as saying something like, this website cannot be trusted, only, you should not go here, for some reason like that? So that's because that website probably doesn't have a certificate that was signed by what's called a certificate authority. And I think I can actually simulate this. I just happened across this the other day because I wanted to make one of my university websites run over SSL. So let me open up Chrome here and type in https cs.harvard.edu. Enter. Perfect. Perfect example. So CS department has not paid for what's called an SSL certificate, ironically. And I would fix this, but it's a great demonstration. So what does this mean? It means that the site isn't necessarily insecure per se. It pretty much boils down, and this is somewhat pessimistic, to the fact that we have not paid for an SSL certificate. We have created an SSL certificate whereby that's just a command. On a Linux computer, you typically run a command called OpenSSL with some fairly arcane command line arguments and hit enter, and that gives you what's called a public key and a private key. What does that mean? Well, for our purposes here, just know that there's a fancy mathematical relationship between this thing called a public key and a private key. They're really just big random numbers. And mathematically, people on the internet can use CS75's public key to encrypt information to us. So if some random user is trying to visit Harvard's CS website, their browser automatically will say to cs.harvard.edu, can I please have your public key? And the browser will send it for free and over the internet publicly. It's not something that's secure. Public key is meant to be, by definition, public. That browser will, behind the scenes, unbeknownst to the user, use that public key, that big random number, to encrypt their request. And the request could be something stupid like get/, and that's literally all my request just now was. But it encrypts it nonetheless. And you can probably guess, what is the only number in the world that can decrypt something that's been encrypted with the public key? The private key. And that's something my server or the CS department server keeps to itself. And you don't give it out, and the web server is never going to send it. It's stored somewhere on the hard drive. Now, mathematically, that key will be used with a mathematical formula to reverse the effects, essentially, of the encryption, so that what the CS department's web server finally sees is get/, or whatever it is the user wants. And conversely, it works in the other direction. When you install a browser, your browser generates a public and private key pair so that the traffic can work in the opposite direction as well, if necessary. So what's the takeaway here? We did all of that in the CS department, but we didn't pay someone else to certify that we are Harvard University's CS department. So the way SSL works on a higher level is that there's this chain of trust that humans in the world have tried to build up, whereby there's big companies like VeriSign is one of them, GoDaddy's another, and maybe even Namecheap does this, even more cheaply than others, whereby you have these fairly big entities in the world who charge you money to then stamp, so to speak, your certificate as valid. What does that mean? They digitally sign it. So there's actually some interesting mathematics there that are involved, but at the end of the day, it's in part a marketing thing whereby we, the whole world of internet users, are trusting that if VeriSign says this SSL certificate belongs to cs.harvard.edu, if I trust VeriSign, I should trust this website. Now, how does VeriSign do the authorization? Well, some of these registrars or these sellers of SSL certificates, they'll go to reasonable lengths to make sure. They'll call you on the phone. They'll check some business records. That's what you get if they're really being diligent. But the reality is all they do is send an email typically to whoever is on file as the owner of the domain name. And in this case, it's Drew Faust or someone like that for harvard.edu. And that person has to say, yes, I own this domain and I approve the digital signing of this certificate. And then you get back your digitally signed certificate. And what you do as the system administrator is you install that digitally signed certificate, which frankly is a big number supplemented by another big number. And you install it on your web server using the syntax that we just saw, and we'll see again in just a moment. So how do you get this certificate? Well, you can go to someone like VeriSign, and let's do that, verisign.com. And here we have, let's see, lots of products. So, here we go, buy SSL certificates. And okay, you know it's going to be expensive when they don't tell you the price right away on the page. So let's compare all SSL certificates. Okay, so what do we get? Let's see. Let's just spoil the surprise. Okay, here we go. Okay, they're still not. Oh, there we go. Okay, so here's what an SSL certificate apparently costs if you go through VeriSign. And mind you, it's just for 1 year. So you're essentially renting their approval for a year. What you get now is what here? Different encryption strengths. So if you're familiar with cryptography, the more bits in the cipher, in the encryption algorithm, the more secure, in theory, the transmission is. Extended validation, not quite sure what this means, probably has to do with something like the duration of it. The warranty I've never really understood. You're going to pay $400 and somehow they're warrantying your website for $1.5 million. I assume the fine print says something like, if the cryptography we use is broken, fundamentally we will pay out this amount. I'm just making that up. But the reality is this is pretty meaningless, all of this. And the fact that you get the right to put Norton secured sealed on your website is atrocious, because anyone can put an image tag on a website that says something like that. So a lot of this, realize, is trying to create an industry around sending a message of security to end users. But seeing this should never mean anything to anyone. It just means that someone knows how to embed an image on a website. And the takeaway here, too, is that using VeriSign isn't necessarily all that compelling. If we instead go to GoDaddy.com, which again tries to sell you everything in the kitchen sink when you visit their website, at least is more reasonable when it comes to SSL certificates, whereby you can get away with $69.99 a year, or the premium SSL. And in this case, premium SSL, which is a feature a lot of these SSL providers have tried to market in recent years, does really one fundamental difference. What does it mean when you visit a website and the address bar, it not only says HTTPS, but it also turns green and says the company's name in that address bar? What does it mean? Yeah?
It's supposed to mean this site is really secure and you should really trust it.
Right. But in reality, what does it effectively mean based on this?
They paid $100 as opposed to $70.
Exactly. They paid $100 instead of $70 to get that right. Now, before we just said these sentences, how many of you knew that a green address bar meant something fundamentally different? Okay, so even so there's the question. Is it really worth $30 to convince no one in this room that your site is more secure? So I'm being a little pessimistic with all of this, but frankly, I do think this is a bit of a scam, that we've built up this whole industry that in theory is actually a wonderful idea. These chains of trust, whereby if you trust someone authoritative, like VeriSign or the like, you can then trust anyone they trust. But the reality is it's so easy to get an SSL certificate these days, and even until recently, most browsers did not put these crazy sounding messages in front of the user. You might see a little broken link or a broken padlock icon, but they didn't really raise the bar. One thing Google has started doing is putting up a site like this, but I dare say, and this is a made-up statistic, 9 times out of 10 when you see this message, it's just because someone hasn't paid for their SSL certificate for the year, or it has lapsed. I do this all the time. Once a year, our website starts saying this because I forgot to pay the bill for the SSL certificate. But fundamentally, it's a wonderful idea, because it means that you might be visiting a site that is not who they claim to be, because rather you're the victim of what might be called a man-in-the-middle attack, whereby someone has gotten in the middle of your DNS traffic, and even though you think you're visiting cs.harvard.edu, some bad guy sitting in Starbucks has actually led you to his website instead and is trying to trick you into typing in your username and password or the like. So again, the mathematics, the technology itself is wonderful, but the fact that there's this market of paying hundreds of dollars versus tens of dollars is a bit unfortunate that that's where we're at. Yeah?
This message will only appear if port 443 is active and SSL is being offered.
Enabled, exactly.
Otherwise, it will not.
Correct. If the web server itself is not configured to listen, so to speak, on port 443, then you will just get a dead end, and you'll get a generic browser message saying server not found, or something to that effect. So you must, per the configuration we started glancing at least have your website configured to listen on both of those TCP ports. Recall our discussion of ports on Monday. We can do a little introspection here. If I click the X up here and then zoom in, server certificate does not match the URL. Server certificate has expired. Server certificate is not trusted. So we're really not doing so well here. So let's click on certificate information just to see what... Oh, but the irony is, we have a very secure connection to whoever the hell this is on the internet. So let's click certificate information, and we'll get a little more detail. So it looks like this certificate expired in May. So I'm guilty of the same. So I can't really poke fun of them for doing this. But if we click details and scroll down, we see that the certificate they're actually using for cs.harvard.edu should actually be eecs.harvard.edu. That's electrical engineering and computer science. So unfortunately, I've just revealed who's responsible for the certificate, but he's no longer here, so it's okay. But what the takeaway here is that there's a few solutions. Either one, you pay the bill, and then at least one of those messages goes away. And it's not just a matter of paying the bill. You have to download an updated certificate to install on your web server with an updated date for expiration. But more than that, we also have to fix the domain name. And so you have a few options here. You either, one, buy a separate SSL certificate for cs.harvard.edu in addition to eecs.harvard.edu, or you can buy what's called a wildcard certificate. And for instance, the course, CS75, we have this ourselves. It's unfortunately like $199 a year, but what that means for your money is that you can protect and avoid these kinds of warnings for star.cs75.net, any subdomains you want. And we happen to use things like mail and others for back-end technical reasons. So for us, that actually tends to make sense. So there's a few solutions here. And I should say, too, one of the other reasonably compelling reasons to pay more money to a bigger fish than someone like GoDaddy or Namecheap for SSL certificates is that as part of this chain of trust, the various browser manufacturers, Microsoft, Google, Apple, and so forth, they ship their browsers, Safari,